Good evening, everyone. Thank you for coming. It's a particular pleasure for me to be in conversation with Ravi. We've known each other for a long time now, and he is among the early ones who has used data in the context of business problems, issues, challenges for decades now. So I think you will enjoy the conversation that is to come, particularly because it has specific relevance to all of us and to each of us. And hopefully we can explore some of that as we go forward today. This conversation is a little different, even though we will take a 5-minute detour on the technical aspects of AI, just so you are familiar with it. I think most of the conversation will be on the use of AI and the philosophy of AI and where it might fit in sort of the demonic side or the completely benign version of it. So we can go through some of those ideas as well, but the idea is to talk about the use cases of AI well beyond what is pretty obvious in newspapers and sort of our everyday interactions. So what I'd like to do is the following: invite Ravi to just sort of give an opening statement that might set the context for the conversation. Then we will go through, let's say, 4 or 5 thematic issues, and that should take us pretty much about 55 minutes or 60 minutes, and then we will have plenty of time for Q&A. So please, make sure you have your questions ready. Ravi has kindly agreed not only to take in-syllabus questions, but out-of-syllabus questions as well. So encourage you to do that, because AI is such a vast topic and is so relevant to pretty much everything we do today. So welcome again, Ravi, and the floor is yours to begin.
Thank you, Narayan, and thanks to all of you for coming out this evening. This is truly, a delight for me to be in this venue with such an august audience. So when Anindya, Ghose, and I, my co-author, decided to write this book, it was about 3 years ago, actually. The publishing cycle is very long, and this is a very fast-moving technology. So at that time, our thought was, we want to write a book in AI, but everything that we're thinking about today will probably change next month, and then will again change, in 6 months. So how do we think about something that is a little bit more, time invariant and timeless, perhaps? And what we decided on was to take the challenge of trying to demystify AI to everybody, to the layperson, the person on the street, because otherwise you hear either from the media, which has its own agenda, right? And we all know that negativity sells more than positivity. So that's one, so you tend to get, more of the dark news. You talk to, I asked my mom, what does she think about AI? She said it's a very scary thing, I think. Right, so that's the perception that the media and the WhatsApp university sort of creates out there. Or you might get, in some forums, the other side, overly utopian view, enlightened digital nirvana of self-driving cars and, universal basic income. But I think the reality is always in the middle. So our thought was that if we give people agency and understanding in this, both of us have been doing this for close to 20 years. So collectively, we've seen a lot of stories. We've seen how it works well. We've seen how it doesn't work well. So we said, let's try to do this, write the book in a way that it is designed as an airport book, as we call it. And then the other choice was to, what stories should we include? Because a lot of our research and our work is with companies. But then, we said that that's not going to be interesting to the layperson. So I think that's why we landed on this theme of using everyday life, right? And that's why the title of the book is Well-Being. In fact, our publisher, Catherine Woods at MIT Press, she initially was thinking that this is going to be like a meditation book around AI, right? And we said, no, I think our idea of well-being is that, your well-being is good if you have a good job, if you are healthy, if you have a good relationship, if you can find, love, if you can find, meaningful sort of, ways in which you can contribute to others. And so those are the chapters in the book, right? So we thought, and of course, we've also been doing research in those areas. I have a lot of research in online dating, for example. So we know these algorithms are there, they're lurking, they're influencing, how people meet, who they meet, and therefore very big downstream decisions. So I think that was the idea, that we decided to write a book about how AI is already embedded in our day-to-day lives, and I think that's hopefully what we've tried to achieve. So so that's the preamble of like what we wanted to do, and the structure of the book. The opening of the book, like any good academic worth their weight in salt, we wanted to have a framework, right? So for us, a framework is a way of making basically like a theoretical idea more accessible. So the framework that we have in this book is what we call the house of AI. And it's a little cheesy to say, but I like to say that everybody is welcome into the house of AI. The foundation for this house is data engineering, right? Which is the ability to curate this vast amount of data that we are generating every day from using, platforms, from using phones, from using systems inside companies, your ERPs and your CRMs and, everything that gets business done. So there is tons and tons of data. But one thing I have seen in my own experience is that the rate at which data is growing, the level of insights that we can get from the data, actually, that gap between the growth of the data and the insights, that is also growing actually at a much faster pace, right? So people are not able to harness this data to solve interesting problems to the extent they should, right? And so we start by laying down the importance of data engineering, that it's not, and 70% of all AI projects, tend to basically involve curating data in the right way, getting it out of different silos in an organization, which may be, governed by politics as much as technical issues, right? Who has access to the data, who wants to hold on to it, who wants to share it? Because in the end, if I want to build a predictive model for, let's say, whether, somebody will get heart disease, I want to use, let's say, data from medical sources, but I also might want to use socioeconomic indicators, right? That might be really powerful predictors. So this idea of data engineering becomes the foundation of the house. And then we have 4 pillars. So the house is standing on these 4 pillars. The idea that we can go beyond just doing simple visualizations and reports and use the power of machine learning to find interesting patterns in the data, right? This has been a really actually a big win for many companies. Jeff Bezos, when he started Amazon very early in the 90s, he knew that just by finding out simple co-purchasing patterns, right? People who buy book C and F also buy book G. So if Narayan's bought book C, already there's a very good probability that if Amazon recommends book G to you, there is a chance that you might act on it, right? So even today, 30% of Amazon sales come from basically recommendations. Of course, the algorithms they're using are more sophisticated, but even with just simple transaction data, like who buys what, you can go a long way in, for example, recommending products.
TikTok, because it's been banned in India,
so
it's even better than Amazon in many ways.
Oh yeah, sorry. Oh, Narayan, yeah.
So I was just saying he should talk about TikTok, which is banned in India, but has taken it to a whole new level.
Yeah, and recommendations, we can get into that a little bit more. That's a, in actually a very important part of how AI is influencing everyday life. For example, on dating platforms, right? Much more difficult than recommending a book. When Amazon recommends a book, you have to like the book does not have to like you, right? So in dating, it's like, you have to sort of find that very interesting match that will be acted on. So the descriptive pillar, is a very good starting point, but the bulk of the value that we have seen, I run a lab at Minnesota the last 10 years, we've done several projects, hundreds of projects actually. The bulk of those projects tend to fall in what we call prediction, right? I might want to predict whether somebody will, churn from, from your company, right, as an employee. So that could be a people analytics problem. You might want to predict whether, a product will fail, right? And maybe there's going to be a recall that's come out of that. So you might want to, for example, predict or detect whether somebody is fishing, illegal, fish from trawlers, and basically your inputs there are images that are coming from cameras that are put on boats, and we can build a model to detect whether a fish is legal to catch or not, right? So prediction is 70% of the value even going forward in the next 3 years. And by the way, we may think of generative AI as the only thing that AI is all about. Actually, that's a myth. Most of the value that's going to come in the next, I would say, 3 years is from what I call more traditional AI, right? So things like prediction, these machine learning algorithms that allow you to detect anomalies, to recommend things. Also, we woven this idea of separating correlation and causation, right? So that's a part of this framework. We woven the idea that we have the ability to optimize things, right? So if you're running Zomato, you might want to optimize, the schedules that your delivery people are on, and that could be a huge cost saving. So those foundational layers then build these foundational pillars, rather, then allow us to go and tackle even more interesting challenges, right? And so then we get a layer on top of that where we get into deep learning, reinforcement learning. We actually even put generative AI in that layer, and we can get more into what generative AI specifically is. But the idea that we can go to more richer data, right? So traditionally, when people were doing analytics, they were looking at numeric data in columns in Excel, a CSV file. That was the idea of like the input that we would give to these systems, right? But of course, we are generating text, we're generating audio, we're generating video, we're generating images, and all of those become now good fodder to then feed into even more complex algorithms that can but do interesting things, right? So my favorite example is a system developed in Eastern Europe that can actually detect cancer in breast cancer and has done better in many situations than even trained radiologists out there, right? So that would be an example of a deep learning model. So to take those non-structured data and then get insights from that, we need a little bit more math, we need a little bit more computation, better algorithms, and that's available today, right? And then finally, just to wrap up, the roof of the house is this whole idea about fair and ethical and unbiased deployment of data, right? Explainable AI. The idea that, why is a particular, let's say, forecast being shared with a company, right? If you're saying that, your revenue is going to go down by 6%, whoever you're giving that information to is going to ask you the why question, the how question, on what basis question, right? So there's a lot of science now, a lot of very good research being done in fields from, operations research to computation to, social sciences, where people are figuring out how to open the black box of AI and therefore make it more accessible to actually everybody, right? So that is the framework around which we can move further, maybe in the conversation. Narayan, I don't know if there are any questions on that.
No, so let me begin.
Yeah.
And sort of peel the onion a little bit. As I mentioned, we're going to take a little technical detour, but before I do so, if I could get a quick show of hands, how many of you recognize a job description called prompt engineer? Okay, so we got about 50% of the room. How many of you really know the distinction between deep learning and machine learning? Okay, 20% of the room. Okay, so we will take a brief technical detour just so we can set the base equal for everyone. And a great place to start is data, right? Most people, as you know, probably grew up with, some of us, Lotus 1, 2, 3, but others of us Excel,
Yeah.
right? And think of it as something we can touch, feel, and therefore visualize into something. Mm-hmm. And every step of that transformation is understandable. So tell us the nature of data for artificial intelligence.
Right.
And also the evolving nature of the attributes of the way we host data in databases and so on. So
Sure,
This
sure.
is this is the foundational layer for those of you who prefer civil engineering to computer science. This is literally the pylons that go into the ground, the noise that everybody hears in Bangalore all the time. This is that part of it. So.
Yeah, sure. So let's use generative AI as an example to work our way through this, right? So, and generative AI itself is multimodal, so it can generate, not just text, but many other things. But let's take, something like a language model, like, ChatGPT that many of you have used, or Gemini, or Claude. So let's think about like the data there, right? So the starting point for a language model like ChatGPT, is essentially all the written text that you can think of on the web, right? Just imagine everything on Wikipedia, everything on the Common Crawl, everything on New York Times, which is an interesting.
Sorry, the reason why he's saying that in particular is there's a very specific case going on.
Yeah.
Where New York Times has sued ChatGPT for potential misuse of proprietary data.
Yeah, and Anindya, my co-author, is actually the expert witness on the side of New York Times. So his job is to extract their pound of flesh from OpenAI. And so if you think of all of that data, the first step in taking that textual data. So first of all, the job of that language model essentially is to take, let's say, a partially completed sentence and predict the next word or the next phrase, or even maybe, if the input is, let's say, a sentence itself, to predict the next sentence, right? So it is a prediction model for predicting language. Okay? So that is kind of the foundation of what ChatGPT is, right? So the data is like everything that's ever written, right? So think of a sentence. So what we do with that data is we, first of all, basically convert that. In the end, computers and algorithms can only work with numbers, okay? So we have to do, in very simple terms, the text to numbers trick, okay? And the trick here is to take that text that's out there and encode it in the way that, we describe, let's say a house, right? So if you wanted to sell a house, the house would have so many attributes: how many bedrooms, how many, what is the square footage, how many bathrooms, what is the size of the kitchen, and so on, right? So there are features about, anything that we can think about, features of a house, that would be the description of the house. So similarly out here, what we do is we create what's known as an embedding, which is essentially a numeric representation of a word in, let's say, 20 dimensions, just to keep things simple, right? In reality, it may be like, 2,000 dimensions, but let's just think of it as 20 dimensions, right? So we're going to create a numeric representation of every word. Now, what are the features out here? The features are the relationship of that word to other words around it, right? So that's basically the context, right? So you think of a word like, walks, right? That word can appear in so many different contexts. So I want to represent that word in a contextual space, right? Which then assigns meaning in some senses to the word, right? And once you put something in that vector format, you can do math, you can do arithmetic, you can basically add two vectors, and you can say that, the distance that I go, the distance I have to travel from man to woman, if I take that distance and then I start with king, I will get to queen, right? It becomes simple math, right? So that's the first step. So we take all this, and by the way, what I'm telling you is for text, we can take the same idea to images, to pixels of an image. We can take the same idea to bits of sound, right? Basically, we tokenize these, real world things that are out there and convert them into numbers. We model the context that these numbers appear in, so that, now we have a representation of a word in its position in the larger scheme of life, in some senses, because that's what, the written word represents. And then once we do that, then we can use a lot of, GPUs from NVIDIA and, a lot of computation to build models to basically, amongst all the words that, like, if I stop here, what is the next thing I'm going to say, right? The language model is going to basically give me a probability of all the words that are out there, what is the most likely next word, right? And how does that learn that? It learns that from basically, in some senses, parroting what was written before in context out there, right? So just to wrap up, just to sort of, summarize this, we take things like words, images, audio, video, more richer data, represent that in an embedding, which is just a numeric representation that gives it meaning and context, and then we use that as an input into basically a very, very, very large prediction model, in the range of things that we could even imagine, like even a year ago, I would say, in terms of the number of parameters of this kind of model, right? So if you've ever fit a regression model, right, you may have had, in a normal like business context, you may be, let's say, doing, pricing. You may fit like 20, 30, independent variables to predict that Y. That would be a, 30 parameter model. When we are saying, I want to fit a model to predict the next word, we're talking maybe of a 30 billion parameter model, right? That's the kind of regression we're fitting to predict the next word, but we can do it now because of other advances in computing. And that then becomes basically, with other innovations around putting guardrails and, human feedback and so on, that becomes a system that, is, commercialized in the form of ChatGPT, right? So I don't know how clear I was on that, but that's an attempt to sort of break it down.
If I can synopsize,
yeah,
the next idea is a token.
yes.
And what the model is attempting to do is to minimize the distance to that token. Today, that distance is measured as a probability, but there's lots of work going on to take it not only as probabilistic, but potentially other ways to minimize that distance. So for instance, people are using graph theory and topology and various other methodologies to figure out the contextual next thought that should follow the current thought, or the next pixel that should follow this pixel, etc. Right? So that's the way that it works. ChatGPT, while we've all heard is phenomenal, and truly it's the window for most of us into AI, is in many ways very limited, even though it has whatever 400 billion parameters that it's trained on. It's very limited because it substantially deals with text. And he referenced another word called mode. Each mode is text, video, audio, hopefully sometime in the future even smell, but right now not.
There are actually some models.
Beginning to have that as well, where you have the elemental smells, and the tokenization of the smell on the other end of the releases the right combination here, right? So while there is a gap between what the source is and what the end is, the smell can be recreated, so to speak. So all kinds of things going on in the world of AI. If you think of the power of this, it is coming because the compute power is so effective that you can actually do this 40 billion regression, which was not possible. By the way, AI itself is at least 40 years old.
More actually, like it's in the 50s. So I think the Dartmouth conference was in the mid 50s. So a lot of the theory that we are using today actually has been around.
So the coming together of the theory, the data engineering, and the compute is really why AI is alive today and a great idea 50 years ago.
Yeah. Right? Yeah, absolutely. And I think thanks to the vision of people like Jensen Huang and NVIDIA and others who knew that we had to go beyond the model of computing that all of us are familiar with, like with the general purpose CPU, right? So that idea that we need really powerful computers to play video games, by the way, right? So one of the interesting side bits of how tech evolves is that things that we currently think are like waste of time, like our kids are playing too many video games, actually turn out to be the stepping stone for something really big in the future, right? A lot of innovations have come from what we may initially think of as dark sides, right? There's always like the bright side to the dark side, which is kind of interesting actually.
So let's go a little bit beyond ChatGPT, and maybe you can talk about, whatever you want to, Sora, Midjourney, any of these others, and place them in the context of ChatGPT, just to say, for those of you who have not yet intersected with all of these AI systems, these are now B2C systems that you might intersect with, including games.
Yeah.
We will then go to the B2B applications, which really what this book is all about. And just 5 more minutes of the detour before we get there.
Yeah, I mean, I think, theoretically, there isn't, a lot more new to add. The tokens basically can be anything. I think that's one idea that I want to repeat, right? The token can be a piece of music, right? So I've been having a lot of fun with this platform called Suno, and, it's basically like listen, like Suno, S-U-N-O. And you can go in and, let's say, I want to imagine that I'm, in the Kashmir Valley and there's snowfall and I want to create some music that goes with that. And maybe that's the music I want to play in my cafe, right? If it's really cold outside, I live in Minneapolis, right? I mean, I can basically, the same principles that I talked about right now will apply, for generating new music, essentially, right? So then the question, that is interesting actually becomes, the question of creativity, right? Like what will humans do if AI is going to do all of this? And we can get into that. But I think on the technical front, I think the key message is that we have very good now efficient ways of taking the physical world, at least the knowledge side of the physical world. I mean, the industrial side is a whole different animal. Data from sensors, from machines and things like that, which is, again, maybe not get into that. But we can take what we say, what we see, images, video, audio. We have very efficient ways of converting all of these into good numeric representations that also capture meaning. And then based on that, that is the foundation for all this innovation that you're seeing in the AI that you will interact with, right? There are many portions of this AI that also become really interesting for maybe some of you are in the world of analytics. Maybe you have teams that are doing data science for you. One of the superpowers of ChatGPT that not a lot of people know about is that actually it can do really good coding for traditional AI, right? If you give it the right context, you set it up in the right way, you can have it generate Python code, execute that Python code, be very robust about it, debug it, and then give you answers back in a very user-friendly manner, so that somebody who doesn't even know how to, for example, train a random forest model, can actually just access that technology, right? So this is going to democratize access to that, which for me is very exciting, because this has been the story of my life for the last 20 years. I've been trying to teach managers and executives how to use that capability, right? And I think it's a game changer, actually. Yeah.
Good. So we'll stop with the technical stuff. We can go down a rabbit hole on this one. Anybody interested in talk to Ravi afterwards. But let me switch to the use cases, which is probably far more interesting and actually makes up the bulk of the book, which makes it eminently readable, approachable, and relevant to each of our specific lives. So let's start with love, otherwise called relationships. And the reason to do that is twofold. One, of course, in India, we are always obsessed with matching. Usually some version of Shadi.com. So Ravi is available for 2 reasons outside. One, to sign book, and the other to do matching for those who want it, for their nieces or nephews or children. But he also worked with OkCupid even before AI became a thing. Mm-hmm. So he's been working on this context of matching for quite some time. So just describe the matching process and how we used to do it unimaginatively, and then how we are doing it with AI. And might I expect my son-in-law to be a little bit better?
Yes, I think the answer to that is yes. But I think, at least the way I see sort of, the real world, where, a lot of forces influence how matching happens, it's not perfect by any means, right? I mean, I think there's lots of literature going back to Becker and, others, Gary Becker and others who've, studied some of these things decades ago, who basically predicted theoretically, and then it also plays out in real life, that these matching patterns basically end up in, people who are similar will end up matching with people who are similar, by and large, right? Of course, there are always exceptions. So they call this sorting, right? That's called the sorting. And that happens because, in the physical world, who are you likely to meet? You're likely to meet somebody you went to school with, right? Somebody your parents know, somebody who's at the club that you go to, somebody you meet who's at the bar that you go to, right? And the physical world is in some senses, in that sense, limiting, right? On top of that, there are social frictions, right? So, for example, for the longest time, women, by the way, this is nothing to do with Indian culture. This is actually globally true. Women don't, historically have been programmed not to make the first move, okay, at least in heterosexual markets, right? So there's that friction. There could be, friction of being socially awkward, being not, I guess, forward enough to go to somebody at a bar and, maybe, strike up a conversation or flirt or, get, exchange numbers at the end of it, right? That requires a certain type of, social, I guess, capability that, again, a lot of people may not have, right? So actually, that is the baseline. That's the real world. I think so. When you think about like why in the US today, for example, 50% of of people meeting, 50% of matches that basically work out in the real world start online. Okay, it's because actually there are a lot of both physical frictions and social frictions in the real world. Okay, so I think that explains the allure of incentive of these online dating platforms. And what they break are some of these barriers, right? So you can set it up, like Bumble is a very good example. I mean, I don't know how popular it is here, but doesn't exist.
Tinder does, but not Bumble.
Not Bumble. So, Whitney Hurd, who founded Bumble, she designed the platform in a way that the woman has to make the first move, okay, structurally. Like you can't, right? And in my experience, looking at OkCupid data of millions and millions of users, the ratio is 8:1. Like men send 8 times more messages, than, again, maybe there is some genetic wiring, to do this, which can go back a long time.
Early days, Tinder had to create fictitious women.
To get people in.
To have some, even the 8:1 balance, otherwise it would have been 15:1.
50:1, right? Yeah. So to seed the market, so to speak, right? And so I think what these online, so I was talking about Bumble. Bumble, can structurally, be set up to say that, oh, I'm going to break the social barrier of women not making the first move. We'll just design it that way, right? Which you can do online. You can't do this in the physical world. There's no way to do it, right? And so the kind of AI and the analytics that's sitting in the background that's driving a lot of these are essentially the aforementioned recommender systems algorithms, right? So there's lots of very good science, very smart people, including in my department, sitting and designing these recommender systems. And again, in the dating context, it's so one of the cool things is that they can take into account many more attributes than what mattered in the past, which was, where you live, which school you went to, what bar you go to, who are your friends, common friends, and so on, right? So you can take into account how you write, how you present yourself, like what your, imagery is very big. Tinder was basically all focused on, the looks on the photograph. But these are more dimensions than what we had considered in the past, right? So in the past, there were, I would say, 5 or 6 key dimensions that influenced who you end up with, right? And again, we're not getting into like arranged marriage and those kind of things anyway, but now you can have, maybe like 50 dimensions actually, right? That also includes, how you describe yourself, right? Or how you look, or what photographs you put up there. So that allows the breaking of the sorting, right? And it also allows people who don't have that, social capability to meet people, essentially, right? So I think that has been the big innovation, I think, in the area of love. There is a broader spillover into just more, non-romantic human relationships. So we have a chapter on that in the book as well. And I was motivated by this, by a personal story, actually. So, my parents, live in, my mom lives in Jaipur right now. My, father passed away a few years ago. And one of the things about them was that they really love to travel the world, right? So they, my father was a government servant, but he figured out, really, really innovative ways to get to academic conferences all around the world on somebody else's dime. And so as they got old, it was hard for them to, they were the physical pain of traveling abroad started sort of increasing. So Sophia and I, my wife's there, we set up an Airbnb that is right next to their flat, right? And one of the, Airbnb is a very, very sophisticated, there's AI embedded in literally every aspect of Airbnb. So Airbnb on the host side will, for example, model their interface in a way that, tries to give you the optimal message size of the text box that you can use to message somebody. It shouldn't be too big, it shouldn't be too small. That then allows a response to come from the other side, right? So they're thinking about every little detail. But that platform, going back to my story, became a way for actually the world to come to my parents when they could not go out, right? So for them it was really, they honestly didn't ever think of these Airbnb people who were visiting as guests. They kind of would actually want to invite them for dinner and then take them out, and see the bazaars of Jaipur and so on and so forth, right? So there is a lot of science that we have learned actually from how Airbnb operates, including things like actually figuring out algorithmic ways to reduce discrimination, right? So that was a big problem on Airbnb. Initially, they started looking at the data and they found that homes owned by black people are significantly less likely to get booked than homes owned by, let's say, the majority group. And they figured out algorithms to break that as well, right? So that's, I think, those are the two chapters on relationships. There are, a lot of AI being used to, detect lewd behavior in these platforms, and prevent you from sort of, encountering that. There is even AI right now, that is being used by, for example, a platform called Nextdoor. So in the US, there is a local social network, like in your neighborhood. There's a network that allows you to connect with other people who are living in your neighborhood. Initially, it was like a hotbed for racism, right, that platform. So, and I was really surprised that the CEO of that platform became like the Time magazine's person of the year a few years ago. So I said, what did they do differently? Actually, they built algorithms to kind of detect hate speech or even implicit racism while it was happening, and detect it in real time and try to put a break. Are you sure you really want to say this, right? So imagine like if your brain has that little, that pause button, right, that gives you to think. So it's saying that, do you really want to say this? And the moment I think if you give that, if you apply that break, most people will back away, right? And they will say, no, you know what, maybe I can change my tone a little bit, or that, right? So I think that has been on the relationship side, both romantic and non-romantic. I feel there's a lot of innovation actually that's happened, which is fun.
So yeah, so two use cases you heard. One is matching, the other is, call it fairness and non-discrimination. AI does a particularly good job in these two instances. And if some of you know the US medical internship matching program, one of the most complicated matching ideas in the world today, that had to be done by a magnificent mathematical solution. But now AI can approach that very quickly without having to go through those mechanics. So you want to talk briefly about that?
Yeah, I mean, I think, so you have doctors who have preferences for hospitals, you have hospitals who have preferences for doctors.
And you have rank order.
And you have rank ordering, right? So
and sometimes you have spouses wanting to go to the same place. Other times you have spouses who specifically rank order differently. So you have multiple, one or two person preferences, both supply side and demand side.
And in the end, the goal of the algorithm is to basically minimize the pain to everybody collectively, right? So you may not get the best solution, but the Gale-Shapley algorithm that is used actually in the real world to do this matching, it works in a way that anything that you deviate from that would actually, basically, hurt somebody more than they deserve to be hurt in some senses, right? So it kind of minimizes that. And it's a really, really,
And so that with AI just becomes much.
Yeah, you can do that on steroids. You can do that at scale. And we can do this in many other contexts, right? Think about assigning people, your employees to teams, right? What kinds of projects they want to work on. And you can find many settings for something like that out there.
Should we, since you said employees, let's switch to work.
Yeah.
And another very good example of AI is how it might apply in a variety of work contexts. But let's just take a sort of a horizontal rather than a vertical for a moment. So just idea of matching at work, idea of predicting people sort of continuing, lack of churn at work, some just various ideas of
Yeah. So
the workforce.
as we were doing the research for this chapter, COVID was sort of, in the middle of, this whole process, our research, and the nature of work was, being disrupted in many different ways. But one thing that we found was that actually lots of people, so in fact, there are a couple of studies, Indeed.com, which is a platform in the US, had a report, which I was really surprised by, but it said that 65% of people basically start looking for a new job within 3 months after joining a given job. Okay? So there is some, there is a lot of, that means to me, there is some friction in that process, like of how, candidates are finding jobs and, there's what's going on. So that hiring funnel has its share of frictions, like everything in life. And I think, AI has different sort of places where it can intervene and different stages of the funnel. And actually, interestingly, again, some of the innovation that we are seeing play out today came again from an initial like dark side, actually, right? So Amazon built a resume screener several years back, and that made the news for the wrong reasons, because and this was screening resumes for tech jobs, right? So let's say Amazon posts a technical job, gets maybe 1,000 people who are applying. It can only maybe talk to 10 of these people on the phone as the first round interview. So the job of the AI is to figure out who are these 10 people, right? As opposed to a human reading 1,000 resumes, can we improve that process, right? So you can build a model to do that. You can take the text of the resume literally as the input. You can take prior data of good performers and bad performers as the outcome, and you can try to find the patterns that match these text to those outcomes, right? So that was the process that Amazon did. It built the resume screener, it deployed it, and it was in the New York Times for basically saying that, oh, Amazon's resume screener discriminates against women. Okay? Because essentially, what happened was, historically, for reasons that are determined by society, not many women were doing tech jobs in general, okay? And that was true even at Amazon, right? Why was that the case? Because not many women were signing up for, STEM degrees, in engineering colleges or whatever were the conditions for that tech job, right? Why was that the case? Because again, we can keep going back to where the root cause of this, but from an AI perspective, the data that was used to train the model had maybe 10 or 15% women and 85% men, right? So one kind of, lazy learning, feature that happened was the algorithm basically correlated being a man as being a good tech performer, okay? And this was obviously in the news. Goldman Sachs had the same problem with, when it launched its Apple Card, the credit card. Two spouses applying from the house, the wife got denied by the card, actually the man got approved, right? So there is this kind of issue there was this issue in this, people analytics space around, the bias that these algorithms could put. So something like that comes out, you can bet there are a lot of smart people, PhD students who would, say that, what, how can we fix this problem, right? So now, actually, resume screening is a very, very big use case, because what we have done is we've brought in reinforcement learning as the solution to this problem that I was telling you about, right? So what is reinforcement learning? The idea is that we will systematically take a strategy to explore and exploit, okay? So imagine now there are 10 candidates, and I use my old model, and that old model scores them, rank orders them in a particular way, right? And maybe, there is this guy who's got the highest score. The reinforcement learning algorithm will say, what? That person may have the highest score, but I'm going to, reserve 20% of my decisions to exploration. So I'm just going to randomly pick actually somebody else. I'm going to take a chance on somebody else. I'm going to basically invest the cost in learning about the preferences of somebody else, right? And I'm going to do this systematically. And the moment I start doing that, then some more women come into the fold. And hey, you know what? If they actually work, they're amazing in tech. right? They're doing a great job. They probably are less likely to churn. There could be lots of other spin-off benefits, right? And therefore, then actually the system starts correcting itself, right? So that is right at the top of the hiring funnel. I think there's been some really good innovation, going in and making the whole process a little bit more efficient. Okay. Further downstream, once we get into actual work, there is opportunities to use this technology, like I was saying, to match people to teams in the right way, get the right balance, get Gale Shapley type efficiency in matching. We do that in our lab when we have multiple projects and people want to work on some things and we want to try to make everybody happy. And I think there is lots of ideas now on going back to Gen AI again a little bit, right? Thinking about how Gen AI can augment people's, I would say, like for me, I call these, like mundane and boring tasks that I have to do every day to, basically either comply or to, do some kind of, routine service, which I can create my own Gen AI workflows that can automate that, which then frees up my time to, write a chapter of my book or to work on with my PhD student or go and play tennis or whatever else I want to do out there, right? So I think in the nature of work, there is definitely low-hanging fruit in using, generative AI to either, do synthesis of large amounts of data. That's a superpower, by the way, right? You can take, like you want to design a new marketing campaign. You may not have the time to read all the cool academic research on that, but you can upload those papers to Gen AI and say, based on these 3 papers, can you help me design a referral marketing campaign, right? And it'll give you that initial idea, which can then be the new baseline on which you innovate on as a human, right? So I think there is going to be this augmentation of our work on a day-to-day basis from Gen AI, which to me, I think is going to free up our capacity to do bigger and better things, right? Yeah.
So last use case before we go out of syllabus, which is talk a little bit about AI and the medical field, which is another area which has not just promise, but already shown remarkable progress.
Yeah, to me, I think in terms of where we should spend time and energy, if I had to rank order, like if I had my free will and I would direct AI investments, I think healthcare, maybe both physical health and actually even mental health perhaps would be top of mind because that's really directly related to the human condition, I think, right? So like if we can take 50% of all the investments in self-driving cars and move them to like building better models for predicting disease, detecting disease. Right? I was already giving you the example of that mama clinic in Hungary that so in the book we talk about this case where they built a cancer detection model for breast cancer. There were 22 instances, at least in a year, where the trained radiologists had missed detecting those regions in the imagery where there was malignant cells, and the AI caught it out there, right? So augmenting those doctors with that AI capability, actually, in many use cases, there's going to be a time now where if you're not doing this, you're probably going to have a malpractice suit, right? Up your head, right? So there is, and radiology has been the vanguard, because again, very good structured data, very good, large histories of diagnosis of, does this X-ray have a fracture or not, right? I can take the pixels of the image and, build a model that can do as well as some of the best trained radiologists, right? And there are, several papers in JAMA and others that have looked at even things like retinal disease in babies, right? Which is very difficult to diagnose. And you need like super trained, super specialists in elite hospitals to do that. Hey, but what about like those babies in sub-Saharan Africa, right? Or in rural India that don't have access to this care? These models can basically be productized by, lots of innovators like you all out here and can be delivered. So there is this idea of using this technology in diagnosis and detecting disease, in discovering new drugs, right? So the Nobel Prizes that were awarded this year, in chemistry, for example, the protein folding was, basically recognized as a breakthrough technology. So So that's another use case. Some more simple but actually really powerful use cases in helping the life of doctors, right? So one of the prototypes we built in our lab was to take a patient-doctor conversation like this. Like, let's say you're the doctor and I'm the patient, and we're having this conversation. So in the US, the doctors have to, at the end of the day, after spending all their day seeing patients, have to go into this system called Epic, which is an electronic medical record system, and basically do data entry, right? They have to go in there and make sure that everything is captured. Because if they don't, then there are like other downstream implications, including them not being able to get billed properly, right? So because the doctors have to submit these claims to the insurance company to get money. And there's also, worries about like getting sued for malpractice. But this is, you talk to any doctor friends, this is the pain in their life. They hate doing this, right? So what did we do? We built a workflow where you could take the conversation, actually use Gen AI, so to use basically simple Gen AI technology to transcribe that conversation, and then to extract all the features that go into the Epic form, and then we can press a button and fill out that Epic form almost to 90% accuracy. The doctor can scan it and say, you know what, this, I need to add a few more lines to this note. Everything else looks good, and and the disease code is detected correctly because that's the key for billing, and you press a button and you're done out there, right? So that's a big pain point reducer in the system. We can go on. There's so many examples, right? I mean, I think Dr. Joe Halamka, who heads AI at Mayo Clinic, he and I were on a panel in Minneapolis, and he said that their favorite use case right now is giving these. So Mayo Clinic is a kind of a specialty clinic near Minneapolis. So most of the people who go there are really sick. Like they have there are very complicated cases. And a patient might have on average like a 200-page medical chart, and the doctors don't have the time to read those 200 pages before meeting a patient. So guess what? We can use Gen AI to synthesize that, right, and give them the highlights so that they're better prepared to meet the patients, right? So I think there are many interesting use cases, and this is very exciting actually. I think the healthcare part.
So that's what is in the book. Lots of case studies of the type that Ravi just went through. We've only touched 2 or 3 of them. There's several more, so you can sort of dig into them. There's also references to what companies are doing in each of these areas, so you'll get a window into Airbnb or OkCupid or any of these companies. So I think it gets you much closer to the efficiency use of AI, the effectiveness use of AI, and much else besides. So the Indian word I'm going to use is out of syllabus, but the AI semantic would be hallucination. So let's just hallucinate for just a second. And we're going off topic here a little bit. And this is because, I don't know how many of you followed, but this year, all the science AIs actually went to artificial intelligence. Physics, chemistry, and
the Nobels.
The Nobel, sorry. Went to physics, chemistry, and physiology. All of them went to actually AI practitioners in those fields. They didn't actually go to a doctor, or they did go to a doctor, but a doctor practicing AI. And based on that, let me ask you this question. There's also beginning to be broadly 2 philosophical camps, if you will. One headed by one of the Nobel Prizes winners this year, Hinton, and another by a guy called LeCun, who's out of New York. And you want to describe sort of their positions and how this middle of the road is a much more effective way to think about the next several years at least, rather than get drowned in either end.
That's right. I mean, I think, so Jeff Hinton, I think is now maybe kind of emeritus, but he's a professor at University of Toronto. So he was the guy who brought deep learning to the forefront in terms of practical usage, right? So just to give you a little bit of background, there was this very, long-standing computational challenge called the ImageNet challenge, where the task was, and this was a worldwide contest that has been going on for decades actually, right? And the task was for people, to basically take thousands of images and label the objects in the image in the most accurate way, right? So it's a very simple task. So if this is the image that I see, I can talk about, there are people here, there are chairs, there's a camera, so get the best labels possible, right? So that's the ImageNet challenge. And people were making, the accuracy rates for these for, many decades were actually not getting out of the 70s, basically, right? So we were 70% accurate in able to do that. And around 2012, 2013, this Jeff Hinton's group at University of Toronto suddenly, out of nowhere, got into the 90s, okay? And what did they do differently? They actually started using deep learning, right? So this was the first time that people saw,
30 seconds.
30 seconds.
What is deep learning?
Yeah. So what is deep learning? Deep learning is essentially, so the building block of deep learning is, is basically a neuron. So the mathematical representation of, a neuron in our brain, right? So that's like the most fundamental block of it. What is this neuron? The idea is that it takes certain signals, and when these signals get we can estimate the relative importance, the right weights on them, and we fire them through a particular type of activation function. Basically, once these signals become interesting enough, that neuron fires, right? So think of that, right? So there's a mathematical representation of this process that happens every second in our brain, right? So that is the building block. Now, people used to build simple neural networks to do all kinds of things for a long time. Why? Because it was very computationally infeasible to make, bigger neural networks. Like, if you think about the number of neurons in our brains, that's in the order of like millions, right? So we could not build those kind of networks because we just couldn't estimate the weights that are needed to, accurately do anything, right? But then we had like this breakthrough of computation and algorithms, and just, some simple like basic, calculus in some senses that allowed us to become very efficient at estimating these weights for not just one neuron, but a whole system of neurons, right? So many layers of these neurons. And that's why it's deep, right? So a shallow neural network has this one layer. A deep learning neural network may have, 200 layers that are just connected to each other, right? So that's basically in a sense.
If I understand it correctly, you can't necessarily decipher it going backwards.
Yeah,
You can
but
only decipher. The distinction between machine learning and deep learning is machine learning can be disaggregated in both directions, whereas deep learning cannot be disaggregated in the backward direction.
well, I mean,
Is that right?
the most like certain type of deep learning models, the one I'm talking about, you're right about that. Like that's the convolutional neural network that is really good at images. That cannot go backwards. But then people said, oh no, we want to be able to look back as well, right? Because that might give us some very good contextual information. So there have been other innovations that have actually solved that problem as well. And in fact, the large language model, Gen AI, is in of itself a particular type of deep learning architecture called the transformer, basically, that we were talking about earlier. So going back, that's the story of Jeff Hinton, right? So he's a rock star, basically, in the world of AI. And so is Yann LeCun, right? I won't get into the details of his contributions, but they are all in that same camp. And I think what has happened now, at this point in time, is that Hinton has taken the stance that we are getting, this capability is getting to a level that could be potentially dangerous to humans, right? That we might even get towards artificial general intelligence, and if these robots and these AI systems start making their own decisions, then we will start losing human agency and they will start taking over, right? So that's the Jeff Hinton camp. The Yann LeCun camp is saying that no, that is like very, very far from happening. I'm more in the Yann LeCun camp. And instead of worrying about whether AI can, have artificial general intelligence, let's use AI to innovate, right? To solve problems that we are not solving today, like in healthcare we were talking about, right? In all the other domains that we can think about, right? And so innovate and solve other problems rather than, so those are the two camps, so to speak, right? And I think,
if I understand it right, the nub of the difference is that the LeCun camp is saying that what you have is a mirror on comprehension. It is not actually comprehension.
Yes.
And the delta, the distance to comprehension is for these systems is coming because there is the systems don't understand the physical world.
Oh yeah.
And the example that LeCun uses is a baby can observe 3 things and make a pattern out of it. And even with 400 billion parameters, only the algorithmic version of it the computer can understand. He can't quickly follow, a mother's mood, for instance, or things like that. So to Lakoon, while you might get artificial general intelligence, it's a limited thing, which is much more anything that is breakdownable into tokenization and mathematical comprehension, it will actually get enormously good at. So Go and chess and any analytical systems. But the moment you introduce the interaction with the real world, there is going to be that gap. And as for the moment, there is no bridging that gap.
Yeah, and I think another way to think about that more generally for everybody is that, if you think about flying a plane, right? You need more planes and you need more pilots, right? You can't just keep adding more planes, and if you don't have, so if there is like AI intelligence and human intelligence, the sweet spot is when we start getting both of these to work together, right? We need, you can't just, get value out of AI.
That's the augmentation angle.
The augmentation angle, right? That we can't get value out of the AI if the, complementary human capabilities are also not sort of enhanced out there, right? So that's why, like, I'm not a big fan of, automate. Or maybe if you're in Europe, it's more regulate, right? That also, I think, has its own costs in some senses. Of course, we do need some regulation in certain areas, but I think the key word for me is innovate, right? Like, there are many new problems we can solve, and that does not mean that, we're going to have, that means that we can basically find meaningful employment for people. It does require, what in the book we actually call for a Marshall Plan to educate the workforce in understanding this technology, right? And then that starts at school level. So that is actually a kind of an interesting point as well.
Since you mentioned the Marshall Plan on just when the US elections is complete, let me just briefly speak about the political economy. I think we were speaking about this yesterday. There is a political economy angle to this as well, which is that if artificial intelligence goes down the direction where some of these benefits seep into society rather than just be captured at the top, then the political economy will work for a lot of these goals. So it'll be a sort of a self-sustaining thing, right? So if inclusivity and impact and advantage deepen in society as a consequence of all of this, then the political economy system will also be geared towards using all of this. Whereas if this becomes a very elitist capture, to use a favorite term of some folks, it will then become, a bad thing from a political economy point of view, and therefore more and more something that you have to defend against. So these are the discussions in AI, I think, that will continue. We haven't even touched the topic of governance, but the intersection of the political economy and all of this stuff that we've just been speaking about now creates the need for governance, and that governance should hopefully go in the direction of inclusivity rather than of.
Yeah, and that's where I think, like, all of you being part of this conversation, and then even to a higher level, I think leadership in the end matters. Like, I feel like we need more Satya Nadellas of the world than the Zuckerbergs of the world, right? Because I think the vision that they're going to have is going to be of the nature that, we were discussing right now, which is to, create more, augment human capacity and do more things. I think Satya likes to talk a lot about the co-pilot. Right, that's a co-pilot view of the world. Right, it's not autopilot. Right, we don't want to go there. Yeah.
That's the benediction. The first question comes from back there, Manish.
Thank you for fascinating.
Oh, sorry, gentlemen.
Fascinating talk. I'm in the healthcare industry, but my questions are not healthcare related. Can you comment on what? You spoke very positively about everything. I'll challenge you by asking, what are the 2 or 3 things that you feel AI we should be aware of that may be dangerous? And I'll tell you 2 things that are directly impacting me personally. One is I teach, and so students use AI to give answers, let's say, simplistically, right?
Yeah.
That is one area that I feel very challenged in how to test that. That is one example. Other example, I feel we are politically and socially, culturally, a divided society all over the world because of AI.
Okay.
I'm just provoking you, but not necessarily, but that was 2 thoughts.
Sure. So let me tackle both of those. Are two separate questions. I mean, I think like you, I'm also a teacher. I have students who I give assignments to and I have to grade them. So actually, I think that we have to really rethink our educational sort of structures that we have right now, how we evaluate, and to me, there are two angles to this. So one is, how do we adjust our current systems, whatever we're doing right now, to get them to still work in a reasonable way. But actually the other, I guess, angle is how can we use this technology to innovate in our delivery of education as well, right? And I personally spend more time and energy thinking about the latter. And I'll give you an example. I've been teaching basically like machine learning and analytics in business schools for 20 years, right? And I've had a certain way of doing this class. I have all these my use cases, and then in the end, I have to show students like some code, that is in R or Python, and they, many of the MBA students especially don't want to see that code, right? So it's always been a little bit of a battle, honestly, right? This summer, I was able to create a virtual data scientist, embed that data scientist inside Slack teams of MBA students, and basically let them loose. So my job was then to teach them the conceptual understanding of what questions to ask. So that becomes the key resource that can help them succeed. And then a lot of the work that they didn't want to do in the first place can get done by AI, right? So similarly, I think in the book we talk about Khan Migo, which is a similar kind of teaching assistant that's developed by the Khan Academy by Sal Khan, which is at the school level, where teachers have only so much time. They are pressed. They have other things to do. And if students have a question in the middle of the night, there's nobody to get an answer from, right? They may have a burning, like they're stuck in some step of calculus. Khan Migo is designed in a way that will never ever give the answer, but it will guide you towards getting the answer yourself. It'll ask you the next question that you should be thinking about, right? So I think to me, this is very scalable. It's not that expensive. I think this is going to be, the schools that start adopting this are the schools that are going to have, students that are going to be better trained, are going to have better outcomes going forward out there, right? So that is, yeah.
Go to Manish.
Yeah,
Right
go ahead.
behind you.
Yeah.
So I had one performance question and one potential question. You said that in the offline world in marriages, we used to use 5 criteria like sort of caste or height or skin color. Now you're using 50. Is that leading to lower divorce rates? Is it leading to better matching? And the second potential question, I mean, can AI write Shawshank Redemption or will it write Fast and Furious 15? I mean, will it make music like Nusrat Fateh Ali Khan or like Bappi Lahiri or something? Can it do original stuff or will it do more of what is already there in potential? And how far are we? Or will we never get to writing Shawshank Redemption and sounding like Nusrat Fateh?
So I think the answer to the first question is that at least in the early stages of that funnel of matching, you now have more, choices. So there is evidence of, let's say, diversity, for lack of a better term, in that early stage. After that, actually, in many ways, the job of AI or any kind of technology is over, and life has to take over, right? And that is what will then determine, human compatibility and success in a marriage, and there are many other dimensions out there, right? So that may sound like a cop-out, but I think that's the reality, in my opinion at least, right? I think the second question is the creativity question, right? Like what, we know this technology can create things, but is that going to be of, any good quality out there, right? And we can lean on some of the evidence, for example, that we have seen from the music industry, right? So people were similarly worried when, music piracy started happening like 20 years ago, that's the end of production of any good music, right? And that didn't happen. I think we're going to have a similar kind of, story with writing, novels or other things. I don't think the human spirit to do this is going to go away. I think the cost of producing this kind of content is going to go down, and AI augmenting humans is probably going to be, again, we can't predict the future, what's going to be produced, but at least from what we've seen in a parallel industry, creativity has not gone down, and high quality creative output has still been produced out there, right? So this is slightly different, but to me, that's the way I see the world. I mean, in terms of parallels, right?
Could I just
Yeah, please, yeah.
one quick thing, which is we've all been trained very quickly to think of hallucination as a bad word in AI, but they're doing two things. One is you turn down hallucination in education, and you turn up hallucination in creativity. And when you turn up hallucination in creativity, for example, at a very simple level, your palette of colors is well beyond anything that is currently imagined in the human context. So is that more creative, not creative? It's not clear. So I think the simple idea that AI is a photograph or a video of all that is past is not correct. It is an elemental idea of all that is past that can be recreated, recombinated in a very, very different way. So, sorry, 1 second, please. We're going system.
I have two simple questions.
Please.
Number one, are we human beings losing our power of natural intelligence to depend upon artificial intelligence? Second question, what is the role of common sense in the whole scheme of things when artificial intelligence rules the world?
Yeah, so, I mean, I don't think there's any evidence that we are losing our natural intelligence, you know, I don't think artificial intelligence is that big or that widespread or that, you know, impactful at this point in time. And if we are careful about how we deploy this, you know, I think we can steer away from that fear completely, I mean, I think, right? I forgot what the second question was actually, so.
Common sense.
Yeah. I mean, I don't know, you know, is that what, to me, like, I don't know what part of that question is conditional on AI, I think, right? I mean, I think there are lots of other things that are going on, which, you know, I mean, I think, you know, Jonathan Haidt at NYU has talked a lot about, like, the adverse effect of devices on kids, right? So that could be a reasonable worry, I think, that we should think about, right? I mean, I think where people are, again, maybe not interacting enough with other humans, in the way that, you know, many of us maybe in this room have done all our lives, and we build that social radar. I think that if that goes away, I think we could be in more trouble, and that could, I think, again, go down that path. So I think those are my sort of thoughts. Yeah.
Sorry.
Yeah.
Yeah,
Sujata,
so
I think,
Moving the mic around as when you raise your hand. So please,
Yeah.
Vijay.
Okay. So just very quickly, I guess Kahneman talks about fast thinking and slow thinking. And in many ways, what we've been talking about, this new AI, is all about fast thinking, right? And, you know, in some sense, the old-fashioned AI, the good old-fashioned AI,
Yeah.
GoFi is more about knowledge processing and knowledge representation, which is the slow thinking. Is there a synthesis that people are working on, bringing these two together, which...
Go ahead. I mean, yeah. So, yeah, I mean, I think the systems that, the problems, you know, the systems that we create using sort of, I think, the capabilities that we have right now, I feel can have elements of both, right? We can structure it in a way that, you know, we also have kind of that, you know, slow thinking modalities built into that out there, right? And I think, in my sense, it's not that clear that it's the other direction. I think that's what Narayan was saying.
I was asking the question. We don't necessarily agree with your prior. I would think of it as clever thinking. And the nub of the bigger demonic question is it too clever by half? But we'll leave that aside for a moment. It is clever thinking. It's not necessarily referencing a speed. So why would you only methodically chase the truth if you could chase the truth in 4 non-obvious shortcuts? I mean, and you are in particular healthcare scientist that works with molecules, so maybe you can shed a little value on what you're talking about there.
Well, I think, you know, part of it goes back to explainability.
Yeah.
And, you know, the original AI Dartmouth conference at McCarthy and others basically felt that logic and deductive reasoning in logic would be our path to artificial intelligence, whereas this whole business of data-driven pattern recognition kind of AI is what I'm calling fast learning.
I think there are people working on the synthesis.
That was the question.
Yeah, there are. There are actually.
Is there synthesis being
I
created?
think
And you can retrofit the synthesis, which is
It's not clear. I mean, there is no theory that is talking about this synthesis.
Yeah,
And
no,
that
I
was
mean,
my question.
I know there are several, PhD students in labs that I'm familiar with that are bringing in those older ideas into the modern sort of framework that is out there, right? With precisely the, I think, purpose that you're seeing out there. And I think one of the use cases actually goes back to, I think, in like, for example, generating music, actually, right? So if you have knowledge representation that augments these deep learning models, can you do things that you could not do otherwise, right? And I think
Climate prediction.
yeah, climate prediction as well. Yeah,
Oh, yeah, because weather has huge amounts of data and very complex models. If you get a deep learning output that you don't comprehend, given the nature of the answer, you could potentially start reconfiguring the forward-looking path. And you may succeed, you may not succeed, but at least you know what you're after. Mm-hmm. So, we will talk more, but please.
Sujata, I think I have a question. Yeah, go ahead.
Hi, my name is Suresh, and is there anybody else?
Yeah, no, please
You go ahead. We have
You
time.
go ahead, sir. You have the mic.
Okay. So my name is Suresh.
Old-fashioned thing still. The person with the mic still has the power. No?
Sure, yeah. My name is Suresh Joyce, and I've been working on AI for nearly 40 years. I've automated at least 15 different, what we now call subject matter expert skills. And most of them were routine, like engineering skills, like circuit design and machine fault prediction and so on and so forth. But I had a kind of a Hinton reckoning moment when back in '88, I helped automate the job of a master tailor, a designer, a garment designer. I could see writ large in his face, the shock and the reckoning that his job, if not today, back in '89, 10 years hence, he would be just a wheel in a cog of large enterprise that automates design and creativity of garments. And for me, the issue was garments are as intimate to us, as much a part of identity as our health and our names and our knowledge and so on and so forth. So from then I've been in the kind of the Hinton camp, although I continue to build my career in AI opportunistically.
Sir, could I ask you to please
So my
ask the
question is, from that moment of reckoning, I've been thinking, what is it about the human skill set or the human capability that will utterly resist automation and AI? So that's my question to you guys. Not the use cases, they're all great, but what, at the end of the day, when we are left holding the, the holdout bag for UBI or whatever, what is it that we can still do?
So David Brooks, the New York Times columnist, has a really nice piece, which is, the title of that actually tells you everything that you need, which is, in the age of AI, excel in being human, right? So he's getting into the idea that, to get many things done in the world, you need to have some form of empathy, right? Caring for others. You need to have social skills that, again, can grease the wheels of a otherwise like friction-laden situation, right? So there are those dimensions as well. But to me, I think when you started with this question, I get this question a lot. I point to some really interesting research actually done by Professor Lin Wu at Wharton. So she studied every Canadian company over the last 10 years and looked at their rate of AI and actually in particular robotic adoption of robots. And what she found was two things. One, companies that actually started using more robots hired more people, not less people, okay? And which is very counter to the, I guess, the narrative that we hear in the media. And the other story was that the companies that didn't use the robots got wiped out, pretty much, right? And so I think that is the type of equilibrium that we are seeing. And for us, it's I think the obsession around how this is going to basically like replace humans is not that healthy actually to think about, right? I think we can direct our energy to thinking about, okay, what are the other problems we can solve?
But the nature of jobs could change. So take a doctor's job.
Yeah.
Today, there is heavy emphasis placed on the doctor making the pattern recognition. When it's already true, not something in the future, but it's already true that just basically computers, even without AI, can do the pattern recognition better. So therefore, the doctor is better off with sort of exceptional cases or with communicating that and communicating the alternatives rather than the basic pattern recognition. Similarly with lawyers. I mean, I don't know how many lawyers in the room, but lawyers are drafting, cutting and pasting the same corporate document that they drafted yesterday for someone else. This kind of application will reduce, or if not be completely eliminated, so that you will have to go to a different space of service that looks different. So one more here before we get to Sujata, please.
Yeah.
Hi, my name is Venkateshwaran, Venkat. I run an AI training company called Insights AI. My question is, I have been hearing of this term called the hard problem of consciousness, which is supposed to be a very, very tough problem that AI is trying to solve. Can you please throw some light on what this is?
I have no idea.
No idea, okay.
So yeah,
This is the sentient.
sentient thing, yeah.
This is in a way, it's the Lacan question. What is the distance or the gap between understanding, comprehension, and consciousness? Now, I think at last step, we are now going back to what we Indians pride ourselves as our terrain. So right now, we are very far from that. So this is the sentient being question. And I think we won't know till we get closer whether that's possible or not possible. But imagining that that's already there and all dark things will happen within 10 years from that is not, I don't think.
That's right. I think that is absolutely
Whether it'll happen, no idea. Sujata.
Thank you for a really thought-provoking discussion, Ravi and Narayan. I had two questions. One was in the context of the co-piloting that you mentioned, right? And using Gen AI. I think Gen AI in a way that is going to be supportive for work. So all the boring work now gets taken over by AI and you get to do the creative stuff. You get to do the fun stuff. So I think jobs are just going to get more exciting and interesting. Are educationists consulting with you or people like you so that they can learn, so that they can teach children how to use this formidable tool that they have literally at the touch of their fingertips? And the second question is on governance. I noticed that your book doesn't really get into that, but it sounds to me like there is a desperate need for some guardrails to be in place, because when you look at social media and the way it uses AI and the impact it's having on mental health in adolescents and children, the concern is, and these companies are going to end up using it in a way that isn't really going to be supportive to public health.
Yeah, great questions. I mean, I think on the first one, I think this is, I would say the short answer is no. Like in terms of, have I been in touch with a lot of educationists to help them with that? But I think part of being on this tour is to get the word out and get that messaging. I've had, actually the chance to visit with the kids at Neve this morning and talk to the teachers and talk to Kavita. So I mean, I think it's, this technology is already here. I think we have to, start piloting, piloting, bringing it in certain phases within schools, and then learning from that, and then sort of, spreading it out, right? So to me, I think there'll be a lot of, gains for some of the early movers in this. So anybody is listening, please spread the word. I mean, I think, and again, there's lots of good detail in the book as well. I think with this, on the question of governance, obviously, incredibly important. I think, you raise a very good point. I mean, I think in the end, I think what we're going to have to work our way towards is sort of this coalition of basically, entities that have the right values and the interest that can basically be a counter to the people who want to abuse this technology out there, right? So there's like a cat and mouse game between, this is technology. It can, like any technology that we've ever had, it can be used for, good and bad. And and it's always a cat and mouse game, but in the end, the good guys have to win. The way they win is that there are enough, you basically gang up, right, against these people, right? And so you have to have this coalition, in my view, of, entities that basically will impose costs, will be smarter and more superior. So there's a lot of investment happening in, things that can, detect, for example, deep fakes in political environments. Platforms have to get much, much more sophisticated. I think they have seen it, I think Facebook's a good story. I think they now completely realize that it's in their own interest to invest in building, really, really sophisticated teams that can build that, right? I don't think they did that earlier on, but it came at a cost, and I think it's in their own interest to do that, right? So I think there are lots of smart people putting time and energy into it, and investments coming in, I think, right? Yeah.
So last
Hi.
two questions, sorry, there and then here.
Hi, my name is Sharath. I've been in the industry working on data analytics field for a while. My question is that if you look at the regular industry, not the weather detection or health and deep solves of data science for, using traditional AI, Indian industry, if you see the startup at least, is just about 10, 12 years old compared to US, let's say, and a lot of fundamental things, like you said about the foundational things like data engineering, having the data in the right way to access, store, and all of that. They have been taken for granted. Data engineering has not been given the right ammunition to build the foundation before they grew. Now there is an advent of such a Gen AI thing, and again there is a mad rush just to get them inside the system. And I see, my observation might be wrong, but I see that before even they could build a strong foundation, something great has come in terms of the facade. So what is your observation, whether it is in US at least, which is a matured economy, how will this play out? Because I see industry is getting caught in a mad race without having the foundational things in place.
So quick answer, I know we are running out of time, but I think quick answer is that in certain situations, actually, leapfrogging is not a bad thing, right? I mean, I think in India, we went from barely available landlines to really good mobile phones, right? So I think because there are many problems that Gen AI can actually solve that earlier required a lot of data engineering and labeled data and building those models, we can short circuit some of those processes, and there are many use cases, I would say, actually, where Gen AI can help us leapfrog, right? So I think whoever's doing that, language translation is
we didn't get a chance to talk about, but it's been a mega use case in India already.
Already, right? And so I think while chasing the shiny object is obviously not, nobody advises people to do that, but I think to the extent we can find these leapfrogging opportunities, we should avail them actually, right? So yeah, I think that's...
Sorry, you get the last question of the benediction if you like.
Yeah. Good evening, everyone. My name is Rudresh. I am a career development coach. Being the youngest country in the world and the highest graduate output per year, I get this question from my students saying that, what should I build my career over the next 10 years? And I don't have an answer for them, because suddenly the past traditional way of building a career path, you learn, you grow, and you become an expert. That path is getting cut now in haphazard manner by AI is what I'm feeling, because anything I tell them that you should become an expert in this field, they said it's not required, AI will solve that problem. So what should be our answers to younger generation? How should they build their career path in a world which is already taken over by AI?
I mean, I think the short answer is that actually, they should, follow their passion, and none of the careers that we value, like, medicine or, engineering or it's not as if the value of these careers is going to go down, I think, right? The way we do some of these things might get augmented by AI. And so therefore, maybe investing in, doing like dual majors, right? Investing in, let's say if you're studying biology, but you can also study like maybe the computational side of biology, that's a very good thing to do, right? Because then you can use this capability to solve even more interesting problems in whatever the field that you have out there, right? So I think that would be like, I'm not a career coach, but that would be the advice that I would give to young people out there, right? I think it's a misplaced fear that AI is going to do all these things out there, right? It's actually humans using AI in the right way that are going to take us forward, right? So I think basically that's probably a good place to end, maybe. Right?
Good place to end. Ravi is outside to sign some books. We can chat with him at that time. And thank you again for listening.
Yeah, thank you all for so patient.